As you can probably hear, I'm quite sick, so I hope you can still understand me.
Thank you for joining
Today,
anyways. Appreciate it.
yeah, great to be here. Today I want to talk about security in AKS, especially for developers. The reason why I came up with this session is I myself have a developer background, and in my daily job, I see many developer tools who have to manage their own cluster. They don't have infrastructure teams or system teams who can do that. And it's possible with the cloud, but it also allows you to make many mistakes that can compromise the security. And so the idea for today is that I'll just give you an overview of the features we have that are easy to use as developers, and it will make your cluster way more secure. So the plan for today is we're going to start with the authentication and authorization. That's probably the most important topic and also the topic that's configured wrong most of the time. Then we're going to take a look at Entra Workload ID. We take a look at a private AKS cluster, what it is, how it works, and we also take a look how we can manage our secrets. If you're interested in the slides, you can scan the QR code, or you also can find them on my GitHub page. Before I get started, a couple sentences about myself. My name is Wolfgang Ofner. I'm a freelance cloud architect. I'm based in Toronto, Canada, and I focus on Azure. Lately, mostly on architecture, security, and governance, but I also help teams with Kubernetes and DevOps. If you have any questions after the session, feel free to contact me on LinkedIn. And if you're interested in more of these topics, I have a blog where I post regularly, and I also have a YouTube channel where I post a new video every week. And with this, let's get started and talk about authentication and authorization in AKS. So when you create a new AKS cluster, you have the option to select between three authentication modes. The first one is called local accounts with Kubernetes RBAC. That's the default one. This means if you use, for example, the Azure CLI and don't provide any configuration, AKS will use this one. Then the next one is Entra ID authentication with Kubernetes RBAC. And the last one is Entra ID authentication with Azure RBAC. And if you just remember one thing of this slide, remember that Entra ID authentication with Azure RBAC, the last option, is the best one. And the first one, local accounts, is the one that's used most of the time, but it's the most insecure one. And now let's take a look why it's the case. Also, if you use the Azure portal, you have a drop-down menu where you can select the three options. So as I said, the local accounts with Kubernetes RBAC, that's the default option. It's great if you want to get started. It's very simple and fast to set up. But one of the downsides is there's no link between Entra and AKS. So if you want to do any kind of authorization, you have to use the built-in Kubernetes tools. And this is already where it gets complicated for developers. As a developer, I want to use Azure tools. I know my development environment. I don't want to dive into Kubernetes and figure out how this works. And the second downside is that the access token is stored unencrypted in your kubeconfig file. This means anyone who has access to your machine can read it and steal it, or you could check it into your GitHub account by accident, and then the entire world can access your cluster. And this is how the config file looks. You have some basic information like the name of your AKS cluster, the server, and down here you have the access tokens. And now let's switch over to the terminal and let's take a quick look how this looks like and how it can be stolen. So here in this terminal, I already configured the connection to my Kubernetes cluster. So if I do a kubectl get namespace, I get all the namespaces, and I can also do a kubectl create namespace and call it demo. So this works because I'm the administrator. Kubernetes didn't check what permissions I have. It only checked I have the token, and so I'm the admin. If you take a look at the token, it's the same here. And to show you how we can steal it, I'm just going to copy this and then move over to a second machine. And if I execute here kubectl get namespace, I get an error message because I haven't configured a Kubernetes cluster connection. So as expected, it doesn't work. But if I open now the kubeconfig file and I paste the token I just stole, then I save this. And if I do now a kubectl get namespace, suddenly I have full access to the cluster. And I can even delete stuff. For example, kubectl delete namespace demo, and the namespace is gone. And also nobody knows who I am because I only use the token and I don't have an identity behind it. And that's the reason why the local accounts with Kubernetes RBAC is the worst option we have. But it still makes sense sometimes to use it, but you have to use it wisely. So I only use it if I want to quickly show something. Like for example, when I record a demo, a video, I want to show something in Kubernetes. I don't care about the authorization because I will delete the cluster in an hour again. So I just use this. And Microsoft recommends it to use it if you don't have any users in your Entra. But since we are already using Azure, we have Entra, and if I have external users, I could just invite them. So to me, that's not really a reason why you should use this. And the second downside is that the user management can become very complicated because you have to create the users inside the cluster, you have to provide access tokens to the user and manage everything. So again, as a developer, I don't care about all these things and it's just confusing. And in general, it is recommended to disable local accounts for security reasons because they can easily be exploited. And as we've seen, they just give full admin access and you can do whatever you want. Then the second option we have is Entra ID authentication with Kubernetes RBAC. That's a better option, but I have to admit I've never seen it in a real world project. Because either you go full Azure, this will be the third option, or you don't care about the authentication, then you go local accounts. But just so that you have heard about it, that's a mix. So first we do the authentication with Entra. This means we have to log in with our Entra users, but then Kubernetes checks what authorization we have. This means what permission inside the cluster. The way this works is we create the cluster and then an admin configures the rules and rule binding between the Kubernetes rules and our Entra users. But additionally, our Entra users or also groups need the Azure Kubernetes cluster user role in Azure. This role is needed to download the kubeconfig file. So even though we configure everything in the cluster, we still have to use a bit of Azure RBAC. And the reason why this can be a problem is if you take a look here at this role. So here we define a role inside Kubernetes. We give it a name, in this case reader, because we only want this role to be able to read objects. But now it's already getting complicated because I have to know what objects do I have in Kubernetes. So for example, here I have pods, services, endpoints, and then I have to know what verbs can I use on this object to read them. And the first one would be get, that's the most obvious one, but we also have other verbs like list and watch. And it does not end there, like we have deployments, daemon sets, cron jobs. So it's a very long list and you can easily misconfigure it and you have to know a lot about Kubernetes. Again, as a developer, I don't care too much about this. I just want that my users have read access. But it does not stop there. So once you have the role configured, we have to do a role binding. So this means we assign a user to the role. And we have to do this with the Entra ID of our user or group. This means I can't even write my email address. I have to go to Entra, look up my user, find the ID, and then provide the ID here. So all of this, very complicated. And if we test it now, and we do a kubectl get all, then we can see here in the red box that we get a pod. That's everything as expected and great. But we also get 2 error messages because here we don't have access on the replication controller. And down here, we also don't have access on the horizontal pod autoscaler. So this could be that the administrator configured the role wrongly, which is bad, or everything is set up as intended, but then the developer gets an error message all the time, which is also bad. So as I've seen, in general, I don't think it's a great option. One upside is that the user management is easier than with local accounts because you can at least use the ID of Entra. And Microsoft recommends this option if you want a portable cluster. Although I've never seen this in any project. But what portable means is you already have all the rules and the rule binding inside your cluster. And if you want to move, let's say from AKS to the Google Cloud, you create a cluster there and you only have to change the ID of the rule binding. So in theory, this could work, but I just don't see it practically. The downsides are that the auditing of the access can be really difficult because I have to find all the rules, all the rule bindings in all namespaces. So I have to check everywhere. Then I have to check the IDs in Entra. This means once I find the rule binding, I have to go back to Entra, check there. Maybe it's a group. I have to check who is in this group, and it can be quite a pain. And the last option, that's the best option, is Entra ID authentication with Azure RBAC. With this option, we manage everything with the Azure RBAC system. This means I, as a developer, already know how Azure RBAC works because I use it every day. So I can just apply the knowledge I already have and manage my cluster with this. This means I can assign permissions or roles to users and groups, and these permissions apply to what they can do inside the cluster. For example, if I want my users to be able to only read objects, then I can apply the Kubernetes reader role, and that's it. They have read access. And since everything is Azure managed, it's quite easy, quite transparent. That's the recommended way how to secure your cluster. With this approach, again, we need the Azure Kubernetes Service Cluster User role, so the users are able to download the credentials, and then we additionally have to assign what permissions they should have. So if you take a look at the screenshot on the right, I have the cluster user role to download the credentials, but I'm also the cluster admin. This means I can download the credentials and then I have full access to the cluster. As it is common with Azure RBAC, we can use built-in roles, or we can also create our own roles. And these roles can be assigned to the entire cluster or to specific namespaces. The only downside is if you want to apply rules to specific namespaces, you have to use the Azure CLI to do the rule assignment. And you also have to use the Azure CLI to see what roles are assigned to specific namespaces. You don't see it in the Azure portal. But overall, it's just a small downside, and it's very easy to configure and manage with Azure RBAC, and therefore that's the option you should use. Next up, we have Entra Workload Identity. Before we talk about this, let's talk quickly about what identities are and how they're used in Azure. So in Azure, a resource can have an identity. This is similar to your passport. If you want to cross a border, you go to the border agent, show them your passport, and they can verify that you are the person who owns the passport you are who you claim you are. They can check if you have your visas, if you're allowed into the country, and if everything is okay, they let you in. The same with identities. We can assign identities to Azure resources, and they cannot be stolen because they are linked to our Azure resources. On the other side, if you have a username and password, and if you go back to our border example, if I only need a password to be able to cross a border, it's very insecure because they don't know who I am. The border agent only knows I have the password and you'll let me through. But if the person behind me hears me saying the password, they can reuse it and also can get in. And if I just write my password on a piece of paper, lose it, suddenly everyone has access. So from a security perspective, you should always use identities and not username and passwords. In AKS, we can have an identity, but this identity is assigned to the entire cluster. This can be sometimes useful. For example, if you want to allow your cluster to pull images from a container registry, then you can assign this to the entire cluster and not your application itself. But sometimes you want that your applications have separate permissions. For example, if you have a test and production environment, then the test environment should connect to the test database and the production environment to the production database. And this can be achieved with Entra workload identity. With this feature, we can assign identities to our pods. And then the pods can use this identity to access other Azure services. And the great thing about this is they don't need a password. This means you don't have to manage a password. Passwords or secrets cannot get leaked, and you don't have to rotate them to keep them secure. There are a couple of setup steps involved. So first, you have to have the OIDC, that's the OpenID Connect issuer enabled on your AKS cluster. You can either do this when you create a new cluster, or you can update your cluster to enable it. And then you have to set a couple labels and annotations on your pod and service account. Since you don't have much time, I don't want to go into the details, but the way it works is you have a managed identity, and then with the labels and annotations, you assign them to a service account, and then the service account is assigned to your pod. And when your pod makes a request, then Kubernetes sees what identity is attached to your pod and uses this identity. And these are the first 3 steps here. So Kubernetes uses the identity, sends it to Entra. Entra checks if it's valid, what permissions this identity has, and if everything checks out, then it sends back an Entra access token. And this token has all the permissions this identity has. And with this token, our application can access other Azure services, for example, a database, a key vault, or what else it needs. It never needs a password, just sends the token and it gets access. So we talked about the authentication. This means we can log in into our cluster. Our applications can securely access other services. And the last of the big topics I think are important for security is the cluster access itself. By default, a Kubernetes cluster is available from the internet. That's great because we can easily access it. But on the downside, attackers can also try to get in. And therefore, it is recommended to make your cluster private. And a private cluster, the naming can be a bit confusing. So I had a couple teams who were shocked to make the cluster private because nothing would work anymore. But all this does is it makes the API of the Kubernetes cluster private. I'm going to show you in the next slide what this exactly means, but your workload, for example, if you have a website running on your cluster, all of this is not affected. And the second upside of this approach is if you make the API private, then all the combination between the communication between the worker node and the master node are over a prior connection. By default, they are over the internet, which is slower. It could be insecure in theory, but with this, everything stays in the Microsoft private network. And the way this works is we have here on the left side in the red box our master node. In simplified terms, that's the brain of our cluster. And in the green box on the right, we have our worker nodes. This is where our pods are running and our applications are running. And if we make the cluster private, then only this blue box, the API, is affected. And this API controls everything. So when we do a kubectl, like in the demo before, I connect to this API and then execute the command. And also deployments, updates, everything is over this API. The downside of this approach is, since the API is private, I have to find a way how to access it. And there are different solutions. The first one would be to use Azure Bastion, then a virtual machine as a jump box, and then access from the virtual machine our AKS cluster. The entire setup looks like this. It's quite complicated, to be honest. So if you take a look, in the red box on the right side is our AKS cluster. And if we make the cluster private, then it automatically creates a private endpoint that's attached to the subnet of the AKS. And it also creates a DNS zone. Then what we have to do is, in the blue box here, create Azure Bastion. That's a jump box or jump host where we connect securely over the internet. And Azure Bastion redirects our request over a prior connection to another resource. In this case, it's a virtual machine. But then we also have to implement VNet peering. This means we have to connect the VNet from the VM to our AKS cluster. And we also have to configure the DNS for the VNet. That's down here. Otherwise, the VNet can't resolve the private endpoint DNS. I know it's a lot of information quite quickly, but I just want to show you it's possible, but it's quite complicated to set this up. Another option would be to wrap our command in the Azure CLI command AKS command invoke. If you take a look at the screenshot here, is we can execute AKS command invoke. We provide the name of our AKS cluster, the resource group, and then inside the command parameter, we write what command we want to execute. This works. I don't need additional services or tools. The downside is it's quite slow because it's routed through Azure. So it might take up to 10 seconds for the command to execute, and it's a lot to write. So if I have a different command, I have to change everything again. So it's also not the greatest solution. Another option would be to use a VPN or express route. But again, these are additional services. They cost something. Express route needs your ISP involved. Again, quite complicated. But fortunately, Microsoft just released a new feature how we can access our AKS cluster through Azure Bastion without the need of a jump box. And we also don't have to configure the DNS. So all we have to do is use the AKS Bastion command. Then we provide the name of our AKS cluster, the resource group, and the ID of our Bastion. This creates a tunnel connection, and after this, we can just use normally the kubectl commands as if we were connected to a public API or cluster. And the way this works is we have the same setup as before, but we don't need this jump box and we don't have to care to the DNS. So I, as a developer, just connect to Azure Bastion, and then Azure Bastion can directly access the AKS cluster. So it's very easy to set up. There's no maintenance involved, and it's also very fast. Now our API is private, but the container registry is still available on the internet. So it would make sense to also make the container registry private. The reason why we're using Azure Container Registry is most of the time that we want to store our images in a private registry, and also because it's very fast to download the images if both the cluster and the registry are running in the same data center. Another idea of this is if we keep the registry private, everything inside our cluster is private. This means nobody can push any vulnerable images to our registry, and the Kubernetes cluster wouldn't download them. So if you take a look how the whole setup works is, by default, we have a Azure Container Registry that's available from the internet, which is great because developers, our DevOps pipelines can access it, but also, again, attackers can try to access it over the internet. And it seems a bit counterintuitive, but if you have an AKS cluster that pulls images, it always pulls the images over the internet. Even if the cluster and the registry run in the same subscription, resource group, data center, location, everything is equal, it still uses the internet. And the solution for this would be we add a private endpoint to our container registry, and then the AKS cluster can download the images over a private connection. This means no internet is involved, and we also shut down the internet connection for potential attackers. So all our containers are safe. What's great about this approach is, first, obviously, it's more secure, but also our developers don't have to change anything. Because when AKS pulls the image, it resolves the name or the URL of the container registry from the private DNS zone, and it just points to the private endpoint. So we don't have to change anything in the pull. What we have to change or think about is how can we deploy new images or push new images to the container registry. If you use, for example, Azure DevOps and the Microsoft hosted agents, they have to connect over the internet to the container registry. And since we deactivated this, it's not going to work anymore. The solution would be to run your own agent inside the same VNet or in a peered VNet. And for this, Microsoft has managed DevOps pools, which is very easy to set up, very cheap. But again, this would be way too much for today. Just remember that's something you have to think about when you make everything private. Then the last topic for today is how to manage our secrets. So far, we made our cluster private, container registry private. We know how to log in, but sometimes we still need secrets. For example, if you want to access a third-party API or another service that doesn't support managed identities, there are still secrets we have to manage. And with the Key Vault provider for Secret Store, that's an extension for AKS, we can mount secrets, keys, and certificates from an Azure Key Vault to our pods. This means, again, developers don't have to change anything. It's just how we provide the secrets to our pods. There are a couple of advantages of this approach. The first one is we can automatically rotate our secrets, because if we change it in the Key Vault, it is automatically synced to the Key Vault, to Kubernetes, and then the application has the new secret. But if it's needed, we can also create Kubernetes secrets. This means the extension reads the secret from the Key Vault and then creates a secret inside the Kubernetes cluster. And all of this allows us for separation of concerns. This means if you have an infrastructure team, or maybe in the future, the infrastructure team can take care of this. And I, as a developer, just consume the secrets. I don't care where they're coming from. I just know they're there. And the way this works is with our Kubernetes API, that tells kubelet create a new pod. It should be here. And then kubelet tells the secret store driver to create a temp volume. And at the same time, the secret store driver checks the secret store provider. This is our Azure Key Vault extension to get all the secrets. Since the Key Vault extension has our Key Vault configured, we can now download the Key Vault secrets, return them to the driver, and the driver attaches them to our pods. This can be as secret, as volume, or as environment variable, whatever we need or want. And this is everything I wanted to show you today. I just have 2 more slides with ideas in case you're interested in more security, so you know what you should Google, what to look up. But I think I said in the beginning, Kubernetes is such a massive tool. Like we talked probably a week about security, and it goes deeper and deeper into Linux. Today we only looked at Azure features. So yeah, there's way more to be said about. But if you're interested, Azure provides more security features. For example, with Azure Linux, we can install Azure policies. We have the Defender for container to scan our containers. Or if you want to go even further into the Linux side, we can validate our images. We can limit the privileges our pods have. We can also reduce the capabilities, or we can also go to secure computing. This is where we change how the kernel of the Linux works or what access it has. So you can go as far down the road as you want. But yeah, for now, I think that's enough. And thanks everyone. If you have any questions, feel free to reach out on LinkedIn. Or if you're interested in the topics I present today, I have long YouTube videos where I explain step by step how to set it up.
Awesome. Thank you so much.
Awesome.
Really appreciate it. Great session. Just looking here. I don't think any questions came in. But of course, if anybody that's listening and watching has questions after, we're all readily available on the socials.
I know places still use Dropbox instead of like Azure Bastard, so it's so funny when you put that slide in. Because like VPN just SSH tunnel in there, then you tunnel into AKS Cluster. So it's quite cool.
Yeah, it's actually good that the last session was postponed because this feature was released, I think, a week ago. So I couldn't add it to the slides.
Nice.
Awesome. All right, very cool. Well, thank you so much for the session today. We really appreciate it, and especially thank you for coming on, even though you're not feeling well. I definitely know the feeling of going on a virtual meetup or a virtual conference that you have to talk for over an hour, and not feeling too great. So we really appreciate it. Thank you.
Yeah, it was great having me. Thanks.
Absolutely. Thank you.
All right, thank you.